Hey guys, so it's me again, and I am here to talk to you about exponential decay, which luckily is very, very close to exponential growth, except instead of going up really fast, we are going down really fast. All right. So this happens a lot, like when people buy cars and it depreciates. Um, and so the notes that I have on this PowerPoint slide, if you notice the equation right here, again, super similar to the exponential growth. And pause me, take a second. What's different about this? All right. So if you notice the initial value, right? So initial, okay, is the same, right? So wherever you start from. So if you have 10 bacteria, if you buy a car for $20,000, right? Whatever that initial amount, that amount goes here. Okay? And then we multiply that by what we call a common ratio. So normally that's just one number, right? Like times 2 every time, or times zero point 0.8. I think that was one of our examples. So this whole thing, once you take the 1 minus your rate, that gives you your common ratio. That's the thing that is being multiplied every single time, like if you're making a table. All right. The actual rate, same thing as exponential growth. The rate is just how much it is going either up, or in this case, down by, right? So that could be like, oh, okay, the ball was bouncing and it decreased 20% each time, right? So the 20% would be your rate, and 1 minus 0.2 or 20% would be your common ratio. All right, so let's look at a couple problems to figure this out a little bit. All right, so we're talking about the population of a town is decreasing at a rate of 1% per year. All right, so we see this 1% right here. And again, there was a review video in yesterday's lesson on how to turn a percent into a decimal. So you always need to change a percent to a decimal to use it in an equation. All right. And the 1 here, if you notice, the 1 is just part of the equation. And the reason for that is we're basically saying, I don't just want 1% of, in this case, 1,300, right? I don't just want 1% of it. I want 1% less. So we're basically taking 100% of 1,300 and subtracting 1% of 1,300. So this 1 is like 100% of your original amount, all right? Okay, so again, your rate is decreasing by 1%, but your common ratio, right? Like if you were to make a table of this and say, all right, so I start out, let me see, they use T instead of X, so I'm going to follow their lead, and Y. So if I start out with 1,300 people, okay, even though, and I think in the other video for today, even though you're decreasing by 1%, they talked about you're retaining 99% of your population, right? So this 0.99 or 99% is the common ratio that you would be multiplying all of your terms by as you go down that table. All right, so let's just continue reading this. So in 2000, there were 1,300 people. So this 1,300 right here is the amount of people that you start out with. All right. Write an exponential decay function. And even if they didn't say a decay function or exponential, you should know when it says decreasing and at a rate of, that it is an exponential decay function. All right, so be listening for these key words. All right, then find the population in 2008. All right, so we kind of already went over the equation, the structure. We'll go over another example in the next slide. But I do want to point out one more thing, that this 2000, anytime we're talking about years, most times that we're talking about years, whatever year you start out becomes year 0. Okay, so in 2008, that is 8 years later, right? So I go 1, 2, 3, 4, 5, 6, 7, 8 down this T column. All right, so just a little note about years. All right, so think about that while I erase all of this stuff. And if you want, you can even pause and go to the next slide, where you really should be trying to do the problem first, and then press play again, and we'll go over it together. All right, so we're almost done here. Okay. All right, just a few more erasers, and let's go to the next slide. All right, so cool. In this problem, Energy Tech just got a new 3D printer for $35,000. Each year it depreciates, let's see, at a rate of 5%. All right, so it depreciates, and depreciates, excuse me, is a key word for getting less, for the value going down. Okay, it depreciates at a rate of 5%. So I'm going to write my exponential decay function, and unless they give me something else, I'm just going to use x and y. So my initial amount is $35,000. Pretty cool. 2, 3. All right. And now I want to know what the common difference is, right? And remember, the common difference is 1 minus the rate. So 1 minus, and 5% as a decimal is 0.05. Okay. And now the exponent, the amount of, I believe, years, goes right here. Okay. Right? Sometimes it's months. In most cases, it's years. All right. So again, the rate is 5%. 5%. But the common ratio is 0.95. Right? Or you could say it retains 95% of its value, right? So I'll just put it in percent and decimal so you guys can see 95%, right? So this is like how much of its value it's keeping, but it's going down by 5% or 0.05 each year. Cool. All right, so there's your equation. And I'm going to let you guys figure out the approximate value after 8 years. All right. Just know that you are substituting your 8 in for your x. All right. So you can even make a table if you want to find it that way, or you could plug it into your calculator if you want to find it that way. So just remember that when you first get it, no time has passed, and we have 35,000. And then you'd have to put in, 1, 2, 3, 4, 5, 6, right? And go all the way down to the 8th year. Okay, so you have 2 options to find that, and good luck. Bye.